innocent until proven guilty. This is the null hypothesis of the United States justice system. What's a null hypothesis? It is the hypothesis that you accept to be true unless you can prove beyond a reasonable shadow of a doubt that it isn't. This was not always the null hypothesis of justice systems throughout history. In the United Kingdom, or in England, it used to be that the person was guilty unless they could prove their innocence. I think the United States has an upgraded version of that myself. So what does that have to do with your Anova homework? Well, the Anova works on a similar principle in that you have a null hypothesis that you are trying to either prove or disprove, and if you can't disprove the null hypothesis, basically you accept it. If you disprove the null hypothesis, then you have an alternative hypothesis that you accept in its place. In the example of the justice system, if you can prove beyond a reasonable shadow of a doubt that the person can't be innocent, you reject the null hypothesis that they're innocent and you would pronounce them guilty. However, if you can't prove that the person is guilty, then you accept the null hypothesis and they're innocent. In the case of statistical procedures, you almost always would adopt a null hypothesis that there's no difference between the groups that you're testing. There may be some occasions where you might adopt the null hypothesis that there is a difference if that's what you're trying, or if you're trying to prove there's no difference. But basically, whatever it is you're trying to prove, you would generally say the opposite. So in this example, I have pulled data from the onewayAnova.xlsx file that you have access to through your textbooks. And if you don't have access to it or whatever, you can just type in this little section right here really briefly, and it won't take you very long. And what this is it is sales in a bookstore. And I want to point out that these sales are in hundreds, so it would actually be 700, not 7. So what it is it looked at 12 different bookstores and the same book book display in the stores, and then they compiled the numbers of how many books were sold in the stores based on where the book was displayed. So you have 3 groups. You have the displays that were in the front, the displays that were in the back, and the displays that were in the middle. Now, you do have some assumptions here that the bookstores are about the same size. You'd have about the same demand for the books. And so you're assuming that placement is the only thing here that has changed. That is a fairly big assumption. We're going to go with it for now, but that's one way that ANOVAs can be challenged. If for some reason you don't think that maybe the bookstores that placed it in the front and the back were the same in some ways, then you might come up with another explanation for the difference in the sales of books besides just where it's placed. That type of thing is called internal validity, and the best way to achieve internal validity would be to take all 12 bookstores and randomly assign those bookstores as to where to place the books, and then that would help quite a bit with internal validity. It would rule out other possible explanations for why they placed the books where they did. All right, so let's go run an ANOVA. All right, you're going to go to your data ribbon, and you should already have this data analysis up. If you don't, see the previous video on regression on how to add it. You add it the same way you add the solver by going to File and Add-ins, etc. All right, so we're going to go to Data Analysis, and we're going to do a single factor regression, or ANOVA for this one. I'm sorry, single factor ANOVA, and we'll do OK. And your input range is this B6 through D12, and make sure, I always like to see the labels in it. It makes it a lot easier to interpret it. So make sure that you check labels in the front, in the first row. If you don't do that, it's going to skew your data. You will not get the same results. All right, my output range is going to F6 already. That's fine. And you could also have it do a new worksheet or a whole new workbook depending on your preference. Oh, the other thing, this is grouped by columns, not by rows. So make sure you have the columns selected here. All right, I'm going to go ahead and press OK, and there we go. Now I have a beautiful Anova analysis, and so the next question is, what do I do with this beast? How do I interpret it? All right, so the p-value is what you use to determine if you can reject the null hypothesis. It's kind of a similar concept to a regression. If the p-value is 0.05 or less with a 95% confidence window, then you can reject the null hypothesis that there is no difference between the groups. This p-value clearly indicates that there is a difference in the average of the groups based on where the books were placed. So your average sales, if they were in the front, if the book display was placed in the front, would be 900. If the book display was placed in the back, your average sales would be 1,400. And if your book display was placed in the middle, your average sales would be 1,100, because remember, all of these are in hundreds. Next, we need to come up with our 95% confidence window. What that means is that we can be 95% sure that the sales in each area are going to fall within the range that we're going to calculate. So the first thing we need to calculate is our standard error estimate, and that's the square root of the within groups mean squared. So we can find the within groups mean squared in this cell. It's a cell I-18 on mine. All right, so we always start a formula with an equal sign, and the square root formula is SQRT. You may see it pop up, and then we just select that number. Again, for me, it is I-18, and you should come up with 1.56. This is pretty easy. If you want the 68th percentile, I'll do that over here. Actually, do this, and this is 68th percentile, so we don't confuse ourselves. You would simply take the average, start with the equals, take the average of the front plus the standard error estimate. Okay, and I'm going to make this an absolute value so that I can copy and paste the formula easily. And then to get the low, you would do the average again, which is I-10, and then you would just subtract. Now this would tell you that 68% of the sales, or 68% of the time, the sales are going to occur between 1,056 and 700, and we'll call that 44. Now, we want to actually calculate the 95th percentile, so let me show you how to do that. Oh, we can actually just copy and paste these down, as long as we got our absolute values right. And so now what we want to do is calculate the 95th percentile, and that is similar. You're going to take the average of the front, and you are going to add 2 times the standard error estimate. Okay, and again, I'm going to make the standard error estimate an absolute value so I can copy and paste easily. And you should get 12.12. Remember that this is in hundreds, so it's actually 1,212 would be your high estimate, and your low estimate is the average minus 2 times the standard error estimate. This is fairly simple. Again, we can just copy and paste. So your low here would be 587. So you can be 95% sure that if you place the books in the front of the store, that you are going to have sales between 1,212 and 587. Still a fairly large range. All right. Now, we're going to copy and paste that down. So what this is telling us, if you place the books in the back of the store, you can be 95% sure that you will have sales between 1,712 and 1,087. If you place it in the middle, you can be 95% sure that you will have sales between 1,412 and 787. All right, so one more quick thing. If for some reason the p-value is 0.05 or larger. You see an example of this in your textbook. You would generally not use the average for all of them. You would use, or for the individual, because that's indicating there's no difference. You would generally just use the average for all of them in order to calculate the 95 percentile interval. And then you would only have one 95 percentile interval for the whole problem. You wouldn't have one for the groups, because the p-value indicates that there is not a significant difference between the groups. All right. Again, I hope this video has been helpful. If you have any questions, please feel free to contact me, and have a great day.